Hi guys, we're going to try something a little different here. I've got a YouTube video that I want to share and it kind of goes through the lesson. Not that I don't want to teach you, but I thought maybe you might enjoy hearing someone else for a little bit. So I'm going to share this video and I want you to pay attention. You still need to make sure that you have out your lesson because you need to fill it out as you're going. So let me get this going really quickly. I'm going to share my screen. I'm hoping this will work. I've not done this before. All right, so let's watch this video.
Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 6, algebraic expressions, the distributive property, classwork exercises. That means you do them. Pause the video, see if you can do these. Come back and then we'll match or we'll compare our results. Okay, here we go. Using the numbers 1, 2, 3, 4 only once, and the operations plus or multiplication, addition or multiplication as many times as you like, write an expression that evaluates to 16. Use this expression and any combination of those symbols as many times as you like to write an expression that evaluates to 816. Oh, I skipped number 1. It starts at number 2. That's weird. I didn't skip number 1. Okay, well, there we go. Oh, you want to evaluate to 16. Use this expression and any combination of those symbols as many times as you like and write an expression that evaluates to 860. Okay, so let's focus on the 16 first. There's many ways we could do this. And we can use these 1, 2s, 3s, and 4s as many times as we want. But if I only use them once, then I could have 1 plus 2 plus 3 times 2. And that is 6 times 2, that's 12. That doesn't work. So how about changing that to something that would? How would I get 8 from these numbers? And that's how we do this. We have 3, 4, 5, 6. I need 8. So what if I just make the 1 a 4? 4, 5, 6, that's 9. So then I would have to make the 1, 2, a 1. So there we go. I have a 1 plus 4 plus 3. 4 plus 1 is 5 plus 3 is 8. 8 times 2 is 16. So there's 1. Okay, get the idea? And there's many of these. So I will continue on. And now we have to come up with 816. Okay. Well, the first thing I would do is, will 16 go into 816? That's what I'd want to check. 16 and 16 is 32. That's 2. 4 is 64. 5 would be 70 for 80, so it's 5. 5 times 16 is 8. Subtract and get 16. And at 16 will go into 816. 51 times. Okay. So if I just use this and come up with a way of
good grammar and spelling are important. But if you
Sorry guys, for some reason this does have ads, so we're just going to skip it.
evaluating this, doing something to it 51 times, I would get 816. Okay. So how do I get these 51 times? All right, so now if I represent this as 16, to just simplify this, I could take 16 times 16 plus 16 plus 16, which is 48, And we know that there's 51 of them. So 16 plus 16 is 32, plus 16 is 48. 16 times 48 is not going to be as big as 816. There's only 48 of them, and I need 51. So then I could say plus 16, plus 16, plus 16, for example. And you're probably saying, what is he talking about? This represents 16. So I could say 1 plus 4 plus 3 times 2, which is 16. And multiply it by this, added 3 times. So I could multiply that by this plus itself 3 times. So I could write 1 plus 4 plus 3 times 2. That's 116 plus 1 plus 4 plus 3 times 2. That's another 16. That's this one. I'll do it one more time. 1 plus 4 plus 3 times 2. All right, let me get rid of this. It's in my way here. Oops. Just deleted the whole lesson. And get rid of that, get rid of that. Okay. So let's recap here. This is 16 times 16 plus 16 plus 16, which is right here, which is 16 plus 16 plus 16 is 48. Remember, our goal is to get 51 16s. Well, now I have 48 of them, 48 times. I need 3 more. So then I'd say plus this 3 times. 1 plus 4 plus 3 times 2. And I'm going to continue down here. Plus 1 plus 4 plus 3 times 2. Plus 1 plus 4 plus 3 times 2 equals 816. And if you want to take the time to check that with your calculator, but it should come out, because if this is 16, this is 16 times 16 plus 16 plus 16, which is 48. 16 times 48 plus 3 more is the same as 16 51 times, and we know that that equals 816. Woo! Okay, so that was the 4-number game. So now suppose we alter the 4-number game as follows. So number 3 says, define the rules of the game as follows. Begin by choosing an initial set of symbols, variable or numeric, as the starting set of expressions. So how about we use the 3? Instead of the 1, 4, and 2, we use X, Y, and Z. Okay, so then B says, generate more expressions by placing any previously created expressions into the blanks of the addition operation. So I could have 3 plus Y, or 3 plus C, or X plus Y, or X plus Z plus D. Okay, these are just some examples. Generate more expressions by placing any previously created expressions, these, in the operation plus. So I could add 3 to Y, I could add 3 to X, I could add 3 to Z, I could add X to Y, I could add X to Z, I could add Y to Z, I could add anything to themselves. There's multiple possibilities. Okay. So let's play the game using 3, X, Y, and Z as our set of starting expressions. Write the symbols to be used on the board. Okay, so we've done that. And we're going to generate as many expressions as possible following the rules of the game. So 4 says, Roma says that collecting like terms can seem as an application of the distributive property. Is writing X plus X equal to 2X an application of the distributive property? Okay, and yes, Roma is correct, because X plus x could equal 1. Remember, we have 1, 2, 3, and 4. So 3 represents 3, x could be 1, y could be 2, and z could be 4. So this is 1, this is 2, and this is 4. Okay? So x plus x equals 1 times x plus 1.
For those of you that aren't familiar with Grammarly, it's a Ready Assistant that you can easily download as an extension.
Okay, so x plus x equals 1 times x plus 1 times x. Okay, multiplicative identity, just putting 1 in front of it. And therefore, that equals, to factor out the 1, that equals 1 times, or 1 plus 1. We're going to factor out the x. Okay, there's a x in both terms, so factor out that x, so we have 1 plus 1 times x. That's a distributive property. And 1 plus 1 is 2x. So that is true. 5. Leah is convinced that a plus b squared equals a squared plus b squared. Do you think she is right? Use a picture to illustrate your reasoning. Okay, so now we want to see if Leah is correct, drawing a diagram. So we have this diagram, and it says a plus b squared equals a squared plus b squared. So a plus b being a side, since this is a square, that would mean that this would be a plus b. That is the length a plus b. And therefore, this is the length a plus b. So a times a is a squared. And the area of this square is a times b, or ab. And this is b times a, which is also ab. And this is length b, and this is length b, so that's b squared. Okay, which means that a plus b quantity squared equals a squared, 2 squared. Where'd that 2 come from? Oh my. A plus b quantity squared equals a squared plus b squared plus 2 ab's. Okay? And that is obviously not equal to a squared plus b squared because we're missing this term. So is she right? And the answer is no. Number 6, draw a picture to represent the expansion a plus b plus 1 times b plus 1. Okay, so we're going to make the same diagram here, but now we're going to have a side of a plus b plus 1 and a side of b plus 1. Okay, so here's our diagram, and now I need to label it up. So I'm going to take this side, and it's a plus b plus 1. So it's length a plus b plus 1 times length b plus 1. So this is a times b, or ab. This is a times 1, which is simply a. This is b times b, which is b squared. This is b times 1, which is simply b. 1 times b is b, and 1 times 1 is 1. So draw a picture to represent this. And there you have it. Doesn't say to solve. No. It just says draw a picture. Number 7 says draw a picture to represent a plus b times c plus d times e plus f plus g. I think that's length times width times height. So that's a 3-dimensional figure. Okay, I'm going to do this freehand first and explain it as I go, and then I'll show you a nice neat diagram when I'm done. Okay, so we have a length of a rectangular, or a rectangular cube prism. Now I can't call it a cube because we don't know if they're equal. A cube is all lengths, widths, and heights that equal rectangular prism. So if AB is my length, let's start here and go like this, and somewhere there's an A, and there's A plus B is the length of my side, and then my width is C plus D. And I don't know their length, so I'll just call that C and D. So therefore I have an A plus B over here, because that's my height, and I have a C plus D up here, because that is my width. And then, so if I have length times width, well, the height's got to go out three-dimensionally. So therefore, now I've got to go out this direction and split that into three pieces of E, F, and G. If I bring that up so that this is parallel, I've got an E here, and an F here, and a G here. And then I have a three-dimensional figure, where then when I complete this, it's going to look like this. This line's going to come all the way up here, all the way up here, all the way over here, and all the way over here. And that's going to go back like that. So there's our diagram. Okay, so let me make that a little bit neater. And voila. There's our diagram. Okay. Now it says a key belief of arithmetic, the distributive property. If A, B, and C are real numbers, then A times the quantity B plus C equals A times B plus A times C. Okay, so that's the distributive property. So with that said, we could go back up here and we could find what this expansion would be. Okay, so I'm going to do that just in case. So let me just move this over here.
We're going to make that out of every.
All right, so I'm gonna go ahead and stop the video there. Like I said, sorry there were ads in there. Hopefully that helped. You got a little bit different than me. You know, we'll see. We'll try it this week.